So today, I kind of want to break into acceleration with you guys. We've talked about position, we've talked about velocity, we've even talked about acceleration a little bit. But I want to kind of bring it up in terms that you're really already familiar with, okay? I could talk about a car slowing down. Its brakes, if a car's already got speed, if it slows down, right, the reason it slows down is because those brakes clamp onto the wheel, generate friction, and cause a deceleration, which don't let deceleration confuse you. In fact, I want you guys to think about everything in terms of acceleration. Everything is an acceleration. There is no difference between deceleration and acceleration, okay? The only thing that deceleration will ever mean is that you are coming to a stop. You're going to be working your acceleration. It's going to be going against the direction of motion, right? If you're moving this way and you're decelerating, you're accelerating against the motion. So you're coming to a stop, okay? And this is another thing I want you guys to do, okay? Before we get into all of this, I've got 3 strategies I brought up that I want to bring up to you guys too. All problems in physics, every single one of them, I want you to do this, okay? I'm not kidding. Every single problem, it'll solve so much in your life. You remember when the math teacher told you to show your work all the time? They weren't lying, okay? It will save you so much because that part of your brain, that spatial temporal, is still growing right now. So the part that deals with space and with time and how things move through it, it is still growing. So if you can give yourself a visual example of it, it will save you so much effort, okay? So that's one thing. Okay, so first off, our strategies for how to solve all physics problems. Number 1, write down or draw everything out on paper. It doesn't have to be paper, no. I mean, it could be a chalkboard, it could be a whiteboard, it could be whatever. But draw it out, write it down somewhere you can have it for as long as you need to solve the problem and maybe look over it, okay? Again, this will help you to solve some of this stuff when you see the picture in your head, okay? And if you can't see the picture in your head, draw it on paper, definitely. If you can see the picture in your head, good luck keeping it there while you're dealing with all the other facts, okay? Draw it out so you don't forget anything, all right? Step 2, okay? Step 2 is, what is step 2? Question mark. Step 3 is make blank. No, I'm kidding. Step 2, I want you to take and write all numbers in the problem and label them. What do I mean by that? If I say I started at time 0 and I'm working for 5 seconds, okay, first off, right there, you've already got something. One number you had is you had 0 seconds, and then you went to 5 seconds. I might even write it out this way, right? And I'd say this is t initial, that's where I start, and this is my time final, right? How long am I going for then? Total time is going to be 5 seconds if I start at 0, right? And I start at a position of 1 and I end at a position of 10. Again, write them out. These are x initial and x final, okay? That's important. Label them with the terms you see in these equations, okay? So write everything down you hear about or see in your problem, and then label them equals x final or x initial. I just did that backwards. X final or x initial. V initial, t initial, right? Or t final, or just t, right? If it just gives you the amount of time that's gone by. Acceleration. And again, V final and V initial are important things too, right? So if I tell you a car is traveling for 5 seconds and it goes from an initial velocity of 0 to a final velocity of 10 meters per second, again, those are things you want to write out, right? You'd write out Vf is equal to 10 meters per second. V initial is equal to 0 meters per second, right? Time that's gone by, I think I said 5 seconds, if I remember right. I'm rambling it off instead of reading it off of a word problem. But again, hunt through your problem and find every single one of those terms that you can that's given to you, okay? Write them out. And another thing I want you to hear, anytime you see the words stop or at rest, what I immediately want you guys to do is realize that both of those things mean velocity at that point is equal to 0 meters per second. So even if it doesn't tell you velocity is 0 meters per second at the end or at the beginning, remember it says it comes to a stop, that means it's ending with 0 meters per second, right? Or it starts at rest. That means it starts out with an initial velocity of 0 meters per second. Okay, don't forget those things. All right? So make sure you write everything you've got in your problem down, because then that will give you a set of tools that you can work with, and it'll allow you to choose which equation to work with, okay? So if I had this, if this was all the information I had, I knew how much time had gone by, initial velocity, final velocity, which equation could I really possibly solve here? Take a look at those three equations that we're going to use all the time and tell me which equation we can actually get away with solving. Okay, hopefully you said this one, because it's the only one. And what would we be solving for here? What term do we not have given? There's only one we don't have, right? And that's the acceleration. So if we had all these terms, we could actually figure out our acceleration for this problem. You just plug in, and the third thing I would do, actually I said this is going to make 4 things, okay? 4 things to do. I have my finger down holding the eraser there, right? 4 things to do, okay? See if I can keep track of everything, okay? When you write out an equation, write out the equation. Write out the equation, okay? So I mean, actually write this out every single time. So if I had that problem before, and thankfully I can still see it here a little bit. So I'm going to use this V final equation. Okay, I'm writing out the equation. The numbers I had, final velocity, what I had was actually 10 meters per second. So you see what I just did there, guys? I erased V final and I wrote in my number. Okay? Another thing I would do is V initial. Again, I knew what V initial was. It was 0 meters per second, or it was at rest, or it was stopped. Okay? And I knew my time was 5 seconds. So I have 5 seconds, okay? So with this, I could solve my equation now. But again, it really helps if you do 2 things. If you write out all the numbers and then label them as equal to one of these variables, okay? And then that'll actually tell you what equation to use. Then write out the equation you're going to use. Literally just write it out exactly as you see it there. And then erase certain things and plug the numbers in exactly as you see them. If you do that, you won't go wrong. And you're going to see here that the only thing you can solve for now is acceleration. Okay, so if I do that, I have to move this over, and really it's 0, so I can forget about it. But then I have to move this, it's times 5 seconds, I got to move it over. Since it's multiplied, I have to then divide, right, to get it to cancel out. And what I do to one side, I have to do to the other. So 5 seconds over here. So, and then your acceleration, very easily, you found what your acceleration would be. It would be 2, 10 divided by 5, right? And it'd be meters per second, meters per second squared. Okay, so that's how I want you to solve those equations. Now, 4th thing. Some of these things are going to be really hard to see. So as I said, write everything out, draw it out, whatever you have to. When you draw it out, put arrows down for everything. And label them. Okay? So, before I draw this out, in fact, I'm just going to go ahead and do it, okay? Let's say you have a car backing out of a driveway, which I think was maybe one of the problems that you guys have come across, right? So if I have this, I'm going to actually draw out a car. It doesn't have to be anything too fancy. You're going to be able to make fun of me plenty of times in this class, okay? So here's the headlights. So this car is actually backing up, okay? And let's say it goes with, let's say it starts with a velocity, V initial was this way, and it was 0 meters per second, okay? V final was this way, and it was 2 meters per second, okay? And you said that the time passed was 2 seconds. Now, could I find my acceleration from that? Absolutely. Absolutely I could. But let's take a look at this later on, okay? Maybe it had already started backing up. Its initial velocity was 2 meters per second, and it had an acceleration of, 1 meters per second squared, okay? But now you want to know how long it's going to take to stop if this is a negative 1 meter per second. So which way is the acceleration working? Well, it's a negative. This one we labeled as positive, so therefore the acceleration, again, draw it out, even if it's just an abstract concept, right? A is equal to negative 1 meters per second. It has to be working against V to get V to cancel out, and for V final to come out as 0 meters per second or stopped, okay? And so from this, you could actually find out, you have V initial, V final, and A. Now you could find time. right? How long did it take for it to stop? And what you would find out if you plugged it in is hopefully 2 seconds, all right? But again, draw it out, label it out, write it all out so you can see it, write the equation out so you can see it, and then plug the numbers into that equation, okay? If you do those things, you will not go wrong, and physics will be a breeze, I promise. It'll get so much easier. Okay, so with that, don't forget these steps, okay? And then we're going to come back. You can rewatch this or re-see that part and write those out. But what I really want to get to today is acceleration in one dimension, okay? So the example I think you guys are all familiar with is gravity. And again, if this seems like it's in the y direction, it is. You're right, okay? That is probably what we consider to be y because of gravity, right? Because gravity exists. But don't forget, you can always change your frame of reference, right? So if we do this instead, and I drop this, all of a sudden it looks like it's moving in the x direction, doesn't it? So again, in the x direction now, it all depends on your frame of reference. So this kind of acceleration will still work for one dimension in the x, okay? And maybe it's your car speeding up or slowing down. Maybe it's a rocket, maybe it's something else, right? Okay, so I'm going to talk about in terms of gravity what you're already familiar with. But realize it's still one dimension, but instead of x's, we have y's. No big deal, okay? I'm going to keep it as x even so you can see the equation is still the same. So what happens if we've got, well, let's start out with a simple example. We start out with my pen or a rock or something like that, okay? And I'm going to hold it in place. And I'm going to let it go, right? I'm going to let it go, and I want to know where it ends up. So I want to know x final after some amount of time. And let's go ahead and say after maybe 3 seconds, okay? I want to know my final position after 3 seconds. So the things I want to find x final. Again, remember, write all this down. We know time that's going to pass is going to be 3 seconds, all right? And we're going to go from there. Now, what else do we know? We also know gravity. Anytime you hear gravity in the problem, they will probably not give you the value for gravity. So what I want you guys to use, it's actually negative 9.81 meters per second squared. But we're going to make it a little easier to calculate, okay? So our acceleration due to gravity, note the little g on there, is going to be, we're just going to call it negative 10 meters per second squared. Close enough, okay? So if they don't give you gravity, realize you always have it. It's negative 10, okay? So I have a ball. I'm going to hold it. So what does that mean about our initial velocity? How fast is it going right now? If it starts at rest or is being held, your initial velocity is 0 meters per second, right? Okay, what about our initial position? We know we want to find x final, but what about our starting point? You guys can even see that on the video. Let me move it over. What about x initial? Well, this is also tricky because maybe they don't tell you the initial position, but they want to know how far something's fallen. If you only want to know how far something's fallen, guess what you can do about your initial position? You can set anything to 0 that you want to. This could be 0, this could be 0, this could be 0. It's entirely up to you. Unless they tell you otherwise, you could always set x initial to 0. If it doesn't give it to you in the problem, I would make my life a lot easier and call my initial position 0. It's going to make everything simpler, okay? So, we want to know this guy. We've got initial velocity, we've got time, we've got acceleration, we've got initial position. What formula are we going to use to find final position? This one, right? So let's plug it in. We want to know x final. That's the variable we want to get. We've got our equation, and again, I'm going to write it out, right? And also, I've labeled everything out, right? I also know my arrows are going to be falling down with an acceleration of negative 10 meters per second squared. I know my initial velocity, VI, is 0 meters per second, okay? And I'm just going to write out somewhere over here also my time is going to be 3 seconds, and x initial is going to be 0 meters. Okay? I've got it all labeled out there. Now we can kind of see which direction it's going. And think about this now. By putting those arrows in there, what is the acceleration going to do to the velocity? It's not going to slow it down because it's already stopped, right? It's going to make it speed up, and it's going to speed up in the direction of the acceleration, okay? These two are working together instead of working against each other, okay? So, our equation, plus vi times t, initial velocity times time, plus 1/2 times a times t squared. And again, remember, only t gets squared, all right? So if I put this into this equation, my final position is what I want to know. We don't know it. We know our initial position is 0. We know our initial velocity is 0. We know time is 3 seconds, though it hardly matters here, right? That whole thing's going to turn into 0. And we know our acceleration, we got 1/2 times -10 meters per second squared times 3 seconds squared, okay? So, conveniently that goes away because it's times 0. This one goes away because it is 0. And now our equation becomes a lot easier. Our final position here is going to be 1/2 times -10 meters per second squared times 3 times 3, right? We're squaring it. It's going to be 9 seconds squared, all right? And again, seconds is going to cancel with that when you multiply them, okay? So we're going to end up with -90 times 1/2. We're going to have a final position of -45 meters. And we're left with meters because our seconds cancel, okay? We had seconds on top or seconds over 1. You can always put it over 1. Keep it as a fraction, okay? And that cancels out with the seconds that was on bottom. So does it make sense that we would end up with a negative position if we start at 0 and we drop something off a cliff? Well, hopefully we are going to end up with a negative position because we start at 0 and we're moving with an acceleration that's negative, okay? So we're going to become more and more negative. So if you have this case, you're starting here, right? Ball rolls off a cliff, something like that, right? It's going to just fall and speed up, and it's going to eventually hit the ground, right? How far down? That depends on how long it falls for, all right? So, if we're dropping something, it's going to fall. That's no surprise. It's going to speed up as it falls too. So if I'm going to draw this ball out, its position, so it's going to start here. After maybe half a second, it's going to be here. After 1 second, it's going to speed up though, and the distance between those, even though that's half a second, could have drawn that better. Let's just do that. Let's call that half of a second, okay? But guess what? This is also half of a second between those two instances, okay? And then the next half of a second, guess what? This thing's going to be even farther along. It's going to exponentially increase in distance in the x position as it goes, because the longer it falls, the acceleration increases with time squared. It's going to speed up like crazy. So the distance between these things is going to be small at first, and it's going to be huge at the end, okay? So as things fall, they get farther and farther apart for every increment of time or distance. Sorry, let me X that last one out. Every increment of time that goes by, they get farther and farther apart, right? Their distance increases between those times because it's accelerating. It's going exponentially faster. It's got a crazy curve like this going on for, position versus time. Position's really increasing like mad as you get out there, okay? So, okay, that's for something that's being dropped off of a cliff or dropped from a hand or something like that. What about something that's being thrown into the air? Well, I want you to realize this. If I throw this thing into the air, what's going to happen for every single object when it gets thrown into the air? What do you notice over and again happens with this marker every time I throw it up? What happens? Does it continue to go up in the positive direction forever? Or does it stop? It always stops, right? There's always a point at which you have a peak. For the eraser, same deal, right? You get this parabolic trajectory as you throw it with an X. Otherwise, in the Y, it just goes up and then it follows back down in the same line, okay? If you throw anything up, what goes up must come down, right? And in doing so, at its peak, we have another really crucial thing happening. At the peak, it's got a peak velocity of 0, all right? Another thing they may not tell you on a physics problem. If you throw something into the air and realize I'm going to throw it straight up into the air, but again, just like I was doing with those diagrams of somebody walking, I'm going to draw these things next to each other so you can see them. It's going to look like a parabola. Most things when you throw them with an X do have a parabola, right? Everything has a parabola when you throw it, but I'm going to draw them so you can see them, okay? So first what's going to happen is my velocity, I'm going to have an initial velocity that's positive, and so it's going to make this ball go flying along, okay? But then acceleration due to gravity is working this way. This is my V initial. You see how those two are now working against each other? When I throw it into the air, acceleration from gravity is robbing away my velocity. It's stealing it away. And so that ball is going to get closer and closer together. Just like it did for the rock, it went farther and farther apart. You see how those things look the same? But this is the reverse of it. It's slowing down, okay? And so now I'm going to put this peak, the very peak of this thing is going to be here. So you can see that now it's going to be coming down. And this is a curious thing. The velocity at the peak is 0 meters per second because it stops, okay? But the velocity as it falls, just as gravity took away the velocity, it took it away at the same rate of negative 10 meters per second. Now once it stops, it's going to add the velocity 10 meters per second for every second that goes by. So, weirdly, this is a big difference between velocity and speed. Okay, the velocity is going to continually change because the velocity was going up before, right? A little slower, a little slower, a little slower, a little slower, a little slower until it stopped. Now, velocity changes direction and it gets added back a little more every little bit that goes by until you have the same velocity for every instant, right, after it goes up and then comes back down. So if it takes half a second to get to a stop, it's going to have the same velocity after half a second of falling, right, but in the opposite direction. So the speed at all of these different times would be exactly the same, but the velocity would be exactly opposite. So it's kind of interesting. There may be a problem you come across with a tree with a nut or a coconut or something in it, right? And if you have your nut up here and you throw a rock up at it, well, if you miss it on the way up, but it has a chance to hit it on the way back down, what speed is it going to be at? The exact same speed. Opposite velocity, right? Exactly opposite velocity, but the magnitude or the absolute value of your velocity will be exactly the same on the way down as it was on the way up. Okay? And anything that gets to a maximum height, at the maximum height, at the peak, the velocity is 0 because that object briefly stops in the air. Throw it up and it'll stop in the y direction. It'll stop briefly and then speed back up as it starts to fall. So, important things. Now you can see why a diagram can possibly help you. On both sides of this, realize that your acceleration due to gravity was the exact same. It never stopped working. It did the same thing to velocity on the way up as it did on the way down. It was making it more negative. If it started out positive, well, all good and well, right? It started out positive, but it shrank because it got taken away by 10 meters per second squared every second that goes by. On the other side, it's still taking away at 10 meters per second squared. It's just that you started 0. So now you start to go negative, but it still speeds up now in the negative direction. I hope that helps you guys. I hope that helps you to see this. If you want to find out where the position of this thing is at certain times, again, write out your equation. If you want to know how fast it's been, how fast it is after it's been falling for a while, use this equation. And for gravity, you're going to get negative 10 in there. Okay? That's all I got.